So what is a matrix? A matrix is a rectangular array of numbers like this. We put square brackets around them for notational purposes. Matrices are a very useful tool to store information in an organized way. Let me give you some examples. For example, you can use matrices to represent your Facebook connections. I'll show you how. You've probably seen one of these Facebook friend wheels. Each node in this picture stands for a Facebook friend of this person named Thomas, and each line shows a Facebook connection between his friends. You can turn this into a matrix. By listing Thomas' friends in the horizontal array, I don't have space to list all of them here, so I'll only list some of them. And then listing them again in a vertical array. And then put a number that's either 0 or 1 at the intersection of these arrays. For example, David is connected with Will, so we'll write down a 1 here. Will is not connected with Ellie, so we write down a 0 here. Let's assume that each person is not Facebook friends with themselves, so we put zeros at David with David, Ellie with Ellie, Andrew with Andrew, Will with Will, Faisal with Faisal, and Jin with Jin. These numbers are called entries or elements of a matrix. And if we keep filling up with this matrix, David is connected with Ellie. He's also connected with Andrew, as well as Will, Faisal, and Jin. Ellie is connected with David, Andrew, and Jin, but she's not connected with Will or Faisal. In the end, we end up with this matrix for part of Thomas' social network on Facebook. Now let me ask you, how many connections does David have in this network? 5, you say? How did you get that number? That's right, one way to figure that out is to look at the horizontal array that describes who's connected with David. This horizontal array is called a row of a matrix. Each row of this matrix tells us about the connections of one specific person. For example, the third row is about Andrew's connections, and the fourth row is about Will's connections. If you add up the entries of the third row, the result is called a row sum. And in this example, the row sum of the third row tells you about how many connections Andrew has in this network. Equivalently, in this example, you can also look at the vertical arrays of this matrix. Each vertical array is called a column of a matrix. If you add up the entries of a column, you get a column sum. In this example, the rows and columns happen to store the same kind of information because you might have noticed there's a symmetry in this matrix. This symmetry comes from the fact that you can be a Facebook friend with someone without him or her being a Facebook friend with you. But don't worry, we'll see examples later where rows and columns store different information. Now let me ask you, how many people are there in this social network? And if everybody's connected with everybody, including themselves, how many connections will there be? These are information about the size of the network. And how can you get that information from the matrix? That's right, there are 6 rows and 6 columns in this matrix. So there are 6 people. And if everybody is connected with everybody, including themselves, then there are 6 times 6 equals 36 connections. As you can see, the number of rows and the number of columns in the matrix tell us about the size or the dimension of a matrix. In general, a matrix with m rows and n columns is called an m by n matrix. So this matrix, for example, is a 6 by 6 matrix.